Let's recap what we know so far in terms of angles and the terminal points that correspond to them, and then we'll introduce some new angles and new terminal points that correspond to the new angles. And then we'll talk about how to use symmetry on the unit circle. So on this unit circle, we know the four quadrantal angles. That is, for t equals 0, we know that 1, 0 is the terminal point. Similarly, for t equals 2 pi, we know that this has the same terminal point, 1, 0. We know that for t equals pi, the terminal point is -1, 0. For t equals pi over 2, we know that the terminal point is 0, 1. And finally, for t equals 3 pi over 2, we know that the terminal point is 0, -1. Now there are a few important angles in the first quadrant that you will need to commit their terminal points to memory. So halfway between 0 and pi over 2 lies t equals pi over 4. Remember what that means. That means that in order to walk along the circle, or better said, if you start at 1, 0 and walk a distance of pi over 4 along the circle, then you get to this terminal point that I have marked, and this terminal point is the square root of 2 over 2, root 2 over 2. So that's if you travel halfway from 1, 0 to 0, 1. If you travel a third of the way, then you get to a different terminal point. 1/3 of pi over 2 is pi over 6. And the terminal point for this would be root 3 over 2, 1/2. Again, this is information that you'll need to just know. The terminal point for pi over 6 is root 3 over 2, 1/2. And finally, for the t value, which is 2/3 of the way to pi over 2, that is pi over 3. And the terminal point for this is 1/2, root 3 over 2. Now there are very good reasons for why for these t values we have these terminal points, which amount to essentially drawing triangles in a certain way depending on which angle you're working with. You're more than welcome to check out any standard text on pre-calculus to see the details on that. But once you have an understanding of these, well, let's count them. 1, 2, 3, 4, 5, 6, 7, 8 different angles. You can find terminal points for many other different angles using what's called symmetry arguments. Let's take a look at what I mean by that. And also you should know that these symmetry arguments are incredibly important to have an understanding of the unit circle. So let's get to a page that's not so busy with the unit circle. And let's imagine that I start at 1, 0 and I travel along the unit circle all the way, or let's do halfway, and then I go pi over 4 more. So halfway to 3 pi over 2. So for this angle, I'm going to use a symmetry argument to figure out what t is, that is, what is the angle, and also what the terminal point is. Let's start by figuring out what t is. So t equals, and the way that I'll figure this out is I'm going to break this angle, this distance that I traveled, into pieces. So first I went halfway around the circle and I landed here. That's a distance of pi. And then I went halfway from pi to 3 pi over 2. Now, if you go halfway, that is the same distance as if you went halfway from 0 to pi over 4. In other words, if this t value in the first quadrant is pi over 4, then this one is also going to be pi over 4. So we went pi, and then we went an additional pi over 4. So this t value, getting a common denominator, would be 4 pi over 4 plus pi over 4, which is 5 pi over 4. So we can label this 5 pi over 4. And now we can ask ourselves, what is the terminal point? Well, remember, we know the terminal point for pi over 4. That's root 2 over 2 comma root 2 over 2. But take a look at this new point, 5 pi over 4. However far up you go to get to pi over 4, that's how far you need to go down. In other words, whatever the y-coordinate is for pi over 4, that's going to be the same as the y-coordinate for 5 pi over 4, except negative. So if we want to know the terminal point, the y-coordinate is going to be the same as for pi over 4, except negative, so negative root 2 over 2. What about the x-coordinate? Well, however far you go right to get to the terminal point for pi over 4, that's how far you need to go left to get to the terminal point for 5 pi over 4. Now, since to get to the terminal point for pi over 4, the x-coordinate would be root 2 over 2, the x-coordinate for the terminal point for 5 pi over 4 would be negative root 2 over 2. This is what's called a symmetry argument. And what we're going to do is we're going to develop a systematic way for you to establish these symmetry arguments using what's called a reference angle. Then, once you understand what a reference angle is, you will be able to establish these symmetry arguments with relative ease. So let's break from this particular discussion and let's talk about what a reference angle is and why it might be useful. So the definition of the reference angle, so the reference angle for an angle t, and let's introduce the terminology or the notation for the reference angle. We'll call it t prime for an angle t is the smallest angle that t makes with the x-axis. And there's one tiny clarification that I need to make here. It's the smallest positive angle. Reference angles are always positive. So for example, let's think about what we just discussed with our 5 pi over 4 example. So we'll do a rough little sketch here. There's the unit circle. And 5 pi over 4 was this angle here. Now the reference angle is going to be the smallest angle made with the x-axis, the smallest positive angle made with the x-axis. So that's going to be whatever this blue angle is. And we discussed previously that that angle is pi over 4. So for t equals 5 pi over 4, the reference angle t prime, this notation here is frequently known as t prime. T prime is pi over 4. And the essential thing that we discussed in order to determine what this terminal point was the fact that since this measurement, which is the reference angle, is the same as a measurement in the first quadrant, there is a symmetry. In essence, we knew how far we needed to travel these distances based on the distances in the first quadrant that we already knew, and we had to make adjustments to the plus and minus signs based on if we traveled upwards or downwards. The extremely important result of this discussion is as follows. Let's just label it as a fact. If t has reference angle, t prime, and t prime has terminal point A, B, then t has terminal point plus or minus A, plus or minus B, where you choose plus or minus based on the quadrant. So let's talk about this fact in the context of our example for t equals 5 pi over 4. So for t equals 5 pi over 4, the reference angle is pi over 4. We're going to discuss in detail about how to find this reference angle, but for now we'll just say we know that it's pi over 4. So following along with our fact, if t has reference angle t prime, okay, so t has reference angle t prime, and t prime has some terminal point that you know. So in this case, the terminal point for the reference angle t prime is root 2 over 2, root 2 over 2. That's one of the points in the first quadrant that you'll have to know. So we know what that terminal point is. Then t is going to have terminal point plus or minus the terminal point of the reference number. Then the terminal point for t, which is 5 pi over 4, is plus or minus root 2 over 2, plus or minus root 2 over 2. Where you have to choose plus or minus based on the quadrant. And now 5 pi over 4, that's in quadrant 3. And in quadrant 3, both the x coordinate and the y coordinates are negative. And so you would select negative for both of these, and you could conclude using this reference number fact here that the terminal point for 5 pi over 4 is negative root 2 over 2, negative root 2 over 2.